Today we are going to talk about solving quadratics by completing the square. By the end of this video, you will be able to solve a quadratic equation over the set of complex numbers by completing the square. To start, let's take a look at a couple of problems that you have already seen, probably in Algebra 1. So our first problem, we want to solve for x, and we have x squared equals 16. So to solve, we need to get rid of this square, and we're going to do that by taking the square root of both sides. The square root of x squared is just x, and the square root of 16 is plus or minus 4. It's very important that you have the plus or minus because both positive and negative 4 are a solution to that equation. Let's take a look at this other example. We have the quantity x minus 2 squared equals 5. Again, we need to start by taking the square root of both sides so we can cancel out that exponent of 2. So the square root and the squared cancel, and we're left with x minus 2 equals plus or minus square root of 5. Since 5 is a prime number, we cannot simplify square root of 5, so we'll just leave it as square root of 5. Then we need to add 2 to both sides, and we end up with x equals 2 plus or minus square root of 5. So we have two solutions, 2 plus square root of 5 and 2 minus square root of 5, which are both decimals, so we just write it in this format. What about the next problem? X squared minus 8x plus 4 equals 25. We want to solve this in a similar manner to this problem here. And to do that, we have to use a process called completing the square. So let's take a look at the steps for completing the square, and we'll also work through this example. So the first step is to divide everything by a. So if we look at this example, x squared minus 8x plus 4 equals 25. A is the coefficient of x squared, which in this case is 1. Dividing everything by 1 does not change our equation. So we still have x squared minus 8x plus 4 equals 25. The second step is to move the constants to the right. Remember that constants are any regular numbers with no variables, so in this case our constants are 4 and 25. So I want to subtract 4 from both sides, and I'm left with x squared minus 8x equals 21. Now, this next step is the most important one because it is what is going to allow us to solve this equation by taking square roots. We need to add the quantity b over 2 squared to both sides. So in this case, b is negative 8. So I'm going to do this off to the side here. If I have negative 8 divided by 2 squared, negative 8 divided by 2 is negative 4, and negative 4 squared is 16. So I want to add 16 to both sides of this equation. Then my next step is to factor the left side and simplify the right side. So what we have done here is create a certain type of trinomial on the left side of this equation that is called a perfect square trinomial. If you go through the process of factoring, you're going to end up with two of the same factor. You're going to get x minus 4 and x minus 4. Okay, so I'm going to rewrite this left side as x minus 4 squared. And then if I do the addition on the right side, I get 37. Then the last step is to solve by taking square roots. And this is just like the problem that we did above, right here. So I'm going to take the square root of both sides, and that'll give me x minus 4 equals plus or minus square root of 37. 37 is a prime number, so we can't simplify that square root. Then I'm going to add 4 to both sides and get x equals 4 plus or minus square root of 37. And that's my final answer. Let's look at a couple more examples. We want to solve this equation for x. Our first step was to divide everything by a. So I'm going to divide all of my terms by 2. Then I need to move my constant to the other side of the equation. So I'm going to subtract 13 from both sides. Then I need to do b over 2 squared. In this case, b is negative 6, so negative 6 over 2 squared. Negative 6 over 2 is negative 3. Squared gives me 9. So I'm going to add 9 to both sides. Then I need to factor the left side. And when you're factoring, just as a side note, it will always factor to be x minus b over 2 quantity squared. So when I factor this, this is going to be x minus 3 squared equals negative 4. Then if I take the square root of both sides, the square root and the squared cancel out, and I have x minus 3. Then I need to figure out what the square root of negative 4 is. As we discussed in the last video, whenever you have square root of a negative number, you are going to have an I in your answer. It's going to be a complex number. Square root of positive 4 is 2, so square root of negative 4 is going to be 2i. And don't forget your plus or minus. Then we're going to add 3 to both sides. So our final answer is x equals 3 plus or minus 2i. Let's do one more problem. We need to solve this equation for x. Our first step is to divide by a. And that leaves me with x squared minus 5x plus 2 equals 4. Then I need to move my constants to the right side of the equation, so I'm going to subtract 2 from both sides. Then I need to do b over 2 squared. b is negative 5, so I have negative 5 over 2 squared. Negative 5 over 2 is a decimal, but when we're doing completing the square, it's much easier to deal with fractions, so I'm going to leave it as 5 over 2, and then I just need to square it, and that gives me 25 over 4. So I'm going to add 25/4 to both sides of the equation. Now we need to factor the left side, which if you remember from the previous slide, I said that this will always factor to be x plus b over 2. In this problem, b over 2 was negative 5/2, so this is going to be x minus 5/2 squared. Just a note, I did make an error on the previous slide. This should be x plus b over 2 squared. And then if I combine my like terms on the right side, that's going to give me 33 over 4. Then I need to solve by taking square roots. So I'm going to take square root of both sides. The square and the square root cancel out. I have x minus 5/2 equals plus or minus square root of 33 over 4. Now we need to simplify this square root. Whenever you have the square root of a fraction, you're just going to do the square root of the numerator divided by the square root of the denominator. So square root of 33 cannot be simplified, but square root of 4 is just 2. So then if I add 5/2 to both sides, I end up with 5 plus or minus square root of 33 all over 2 as my final answer.